Hello everyone, welcome to Learn Data Structures and Algorithm in Python course. In today's lecture, we'll be solving another problem on linked list. So this is called linked list cycle. So what is this problem? First, you'll be given a linked list. You have to tell if there are any cycle in this linked list or not. What I mean by cycle? So when you see a normal linked list, there the first node is called head node, right? And the last node is called tail. Now in normal linked list, the tail is pointing to null, always point to null. But if there in linked list, if there is any cycle present, cycle means the last node, what is null, that should be pointing to one node in the linked list. Then what will happen? What will happen? Let's say you iterate through this each node, right? You've gone through each node. Then normally what happens at a certain point, you will got that current is equals to none. You find that. But in cycle, you couldn't find that. What I mean by that, let's say there is a linked list. Let's assume first this is one, then this is pointing to another node, then three, then four, right? Then four, and that is equals to none. Now let's say you take a pointer, current pointer. First, initially it was there, then you move your pointer to here, then it will move to here because you are every time you are doing current equals to current dot next, right? So then it will be here, then it will goes to here. That means you find a null node, right? That is null. That means you'll stop here. Okay. Now let's say a linked list look like this. So let's say a linked list look like this. Yeah. Initially it is one, then it is pointing to two, then it will pointing to three. Okay. Then it will pointing to four. Then again it will pointing to two. Okay. Now let's take a pointer. Okay. Let's take pointer current as this one. Okay. So initially it will be pointing to hit, it will be pointing to hit. Then in the next step, C will be in the next step, C will be here, right? C will be here pointing to node 2. Okay. Then in the next step, it will be pointing to current dot next. That means this one, right? That means this one. Okay. That is done. In the next step, it will pointing to this current dot next. Now in the normal linked list, it should end up, right? But here what will happen when you move your pointer further? So it will be pointing to 4.x, that means 2. That means 2. Again, when you go further, it will be pointing to this one. Okay, then it will pointing to 4 again. So like it is a continuous process, like it will not end up, it will not end up. That means it is fall in a cycle. It is fall in a cycle, infinite cycle, right? Now you have to check if a linked list has a cycle or not. How you can check? How you can check? You can't use current pointer, right? You if you take any current pointer, then it will never end up if there is a cycle. Then how we can do this? To do this, we'll take help of again two pointers approach. Two pointers approach. Where we'll move one slow pointer and one fast pointer. Let's see how we can do that. And every time we'll increment this slow by slow dot next, right? And first move our first pointer by first dot next. Every time we'll move our slow pointer by one step and move our first pointer by two step. Let's see how we can do this. So let's say initially it was one, then it will point into two, then it will point into three, four, right? Then let's say till again pointing to 2. Okay. Now let's say we take two pointers. So this is slow, and let's say this is fast. Initially, both will be pointing to head, right? Head of the linked list. Okay. Let's say let's first move our slow pointer. So let's move our slow pointer by one step. Sorry, by one step. Let's take a general like this. Okay. So is here. Okay. Then we'll move our first pointer from here to here. Okay, from here to here. That will be our first pointer. Okay, this is step 1. Now what we'll do? Again we'll move our pointer. So what we'll check? We'll do this until our first dot next not become null. Right, not become null. Okay, and also we'll have to move our first pointer again, first dot next dot next. So that's why we'll have to condition first dot next not equals to null. So that is the condition, right? Okay, so in the next step, that is the first step. In the next step, we'll move slow by 1. Slow will be here. Okay, then we'll move our first to here. We'll move our first to here. Okay, sorry, not here. So first will be, so initially first was here, right? So first will be moved by 2 element. So this is 1, this is 2, right? So first will be moved by 2 and means here. First will be here. Now I can see first has reverse, right? Now let's say go to next. Okay, so slow will be moved by 1 step. Slow will be here. Now let's move the first pointer. So first will be step by 2 step, right? Move by 2 step. So first will be here. Now when you find that first slow and first are at indicating the same node, basically indicating the same node, that is referring the same node, then we can say that this linked list has a cycle. This linked list has a cycle. So remember, initially we was taking slow as this, first as this, right? So in spite of it, so we'll avoid the initial case. So after initial case, if we find if there any situation where first equals to slow, then we'll tell that this linked list has a cycle. Let's try with another example. Let's say let's take an let's take a simple list. So in simple linked list, what will happen? So where there is no cycle, 3, then let's say 4, then let's say 5, let's say 6, it goes on. Okay, so make it as none. So initially let's say initially slow is here, so make slow is here, first is here. So I'm making the slow pointer as small pointer, okay, and first as large pointer. Okay, so this is first, this is slow. So in the next step, slow will be moved by 1 step, slow will be here, and first will be moved by 2 step, right? So first will be here. Okay, slow will be here, first will be here. Then in the next step, slow will be moved by 1 step, and first will be moved by 2 step. Okay, first will be here, slow will be here. Okay, then in the next step, what will happen? Slow will be moved by 1 step, and first will be moved by 2 step, right? 2 step. First will be moved by 2 step. This is first, this is slow. Now here the loop is ended because this condition is not true. This condition is not true. First has become none, right? So here we don't find any such node where slow equals to fast. That means here we don't find any cycle here. Let's see another example. 1, then let's say 2, then let's say 3, let's say 4, then 5. Okay, then let's say 6, then let's say 7, and the 7 is pointing to 3 again. Okay, let's try for this. This time let's take this one. Okay, so initially slow is this, first is this. Okay, first is this, slow is this, first is this. Okay, then we'll move our slow pointer by one step, right, and move our fast pointer by 2 step, 2 places. Okay, first is here, slow is here, first is here. Okay, in the next step, what will happen? Slow will be moved by 1 step, and first will be moved by 2 step. First will be here, first will be here, right? Slow is here, first is here, slow is here, first is here. Okay, then in the next step, slow will be moved by 1 place, slow is this, first will be moved by 2 place. So initially it was here, then it will be here first. Okay, the next again we'll shift our slow pointer to here, and we'll move our first pointer from here to, so step 1, step 2, right here. First will be here. Okay, in the next step, slow will be from here to here, right? Slow will be from here to here, and first will be from here to step 1, step 2 here. Let's see. So here first and slow are indicating the same node, right? Referring the same node. That means this linked list has a cycle, right? I hope now you have understood the approach. Let's see how we can code this. So to do this, first we have to check if the head node is null or not. For that we have to write, so if not head, so if head is null, then what are we going to do? Will return, so we have to return the boolean value, right? So we'll return false. Okay, then what will happen, then we'll have to take two pointers, right? So one will be slow, it will be initially none, oh sorry, not none, it will be head, then first it will also be head, right? Then condition is while first dot next not none, and first dot next not equals to none. This is the condition, okay, right? Then what we'll do, we'll move our slow by one step, slow dot next, and first equals to first dot next. And in each iteration, what are you gonna check? We're gonna check if slow equals to first. So if we find that those two are referring to same node, then what we'll do? We'll return true. Otherwise, if the first node is ended, that means first node is referring to none, or first dot next is referring to none, then that means this is a simple linked list, right? That don't have any cycle. Then we'll return false. Okay, this is it. This is it. So let's run it. Let's see. Yeah. So let's submit this. Yeah, it is accepted.